Today we will see the structural analysis and building information modeling. The structural analysis, many of you very much aware, and many of you may be experienced in the field, but I will make you sure this session will make you do it in better way, will not miss or some of the things which may not be familiar to you. Under the building information model is one of big topic. Nowadays many of the companies is doing this activity to solve many problems in the buildings. We'll go with what we're going to see in our presentation, which is basically about the structural analysis, which will cover basics of structural analysis and design and the software used and how we do the mathematical model in the software and the properties of the members. Okay, and loads, how we supposed to uh, calculate the loads, in which way we supposed to do the loads in the program. It's a basic one, but it will be a key point to do note while doing the modeling and design. And the later stage we will see building information modeling and building components over the building information modeling. Okay, the first part is about structural analysis. Why we supposed to analyze the structure? Since any mason can do a building without any engineer or somebody else, but why we do need a structural analysis for a particular building or structure? Because we engineers know how the load acting on the structure, which is the most important thing for the fellow civil engineers. Okay, we need to know how the load acting on a structure so that we can able to transfer the load properly to the foundation. The key point first, what are the loads acting on the structure, and understand and the behavioral response of the whole structure and the individual members to ensure the structure is designed properly, analyzed properly. Then only we will be ensured this much column size or this much beam size is enough for our load and request behavioral require and the structure purpose need to be solved in an engineered way. Otherwise, anybody can say some for this much of a single floor building, this much is okay. But what is the important thing? In a single floor structure, which is having 100 ton of weight over it, a mason or any layman cannot design. But we do can justify as per our calculations and science. We can prove that the structure is safe enough to carry those heavy loads. So we need to know what much of load is acting on the structure and how the structure behaves. And we do have a load and we do know how the structure is behaving, and we need to find a proper way to transfer the load from the top to bottom. Whatever loads from the roof or intermediate floors should be properly transferred to the foundation, because the analysis design part not only stops how it behaves, how to find it behaves, but also to find it is safe. How to find it is safe? We have to find a proper way of flow transfer so that the structure will not collapse. We will find a proper member size and the material property required for that load and behavior. So we need to be very sure how the load to be transferred from top to bottom. This is the basic common sense all the structural engineers should have in any time, not only for the structural analysis, but any kind of engineering activity requires this basic common sense. Now I am talking about the site activity also, because some of the structure we are designing and we are transmitting the, I mean, we are communicating to the site with the drawings. Then also need to understand how it behaves, how the load is being transferred, which one they have to build first, and which one should not be built before that. This common sense should all the civil engineers should have, and we do have this sense so that we can do this the load pattern and the load analysis in an easier way. And after doing all the structure, the superstructure analysis, we have to find a proper foundation arrangement, because nowadays we do have a lot of improvement in a soil mechanics, because we can improve the poor soil by lime injection or coke stone column, or we can go with a pile if the soil is too weak to carry our loads. So the question is why we cannot do that, but how we can do that in any situation. For example, for an interesting story about this foundation, in Russia, they are doing on a gas exploration project. For that, they have to design a pile. Okay, the pile should take care minus 300 degrees Celsius, which means it's almost freezing. Anything you put minus 300 degrees Celsius, it will be frozen. That much temperature is there. We have to design a pile for that. So in early stage, if you say in the early engineering, they will say it is not possible to do a project in that location where minus 300 degrees Celsius of temperature is there. It was not possible in earlier stage, but with advanced science in material and the structural analysis and the civil and the structural, we come up with a n number of solutions to do any type of difficult job in anywhere. So for the Russian project, it was the alloy used which can withstand minus 300 degrees Celsius. So it is not the factor where we are doing, but how we are doing. To identify these criteria, we need this basic sense to start a structural analysis program. Okay. In the basics, what I am discussing is a very basic line which will allow us to explore any kind of structure. It may be a mechanical or civil or any kind of structure to be analyzed. This basic procedure need to be followed. Without or with our knowledge, we will follow these steps. Then only we can conclude a proper solution analysis and design. We will do it now as a checklist. So we will not miss, or it is a easy way to start a software learning. Any software, if you can take any software, you have to do this basic checklist, and these checklists to be properly done in the software, because software to software there will be a difference in the parameters, tabs, and procedure. There will not be a same pattern to be used, but there is a common line. If you want to apply load, you have to apply load. but which command you have to use, that is different. But main purpose is you have to apply load. So if you want to take etabs or SAP or StatPro or GT Student, any software, if you want to take these steps to be followed, so that we can learn all the softwares without any hassle. So for structural analysis, we need a software to design. Why we need a software? It depends. It's reduce the complexity of doing calculation by manually, and it will increase the productivity in the company, and it will reduce the error which uh, computational error. It's not a blunder error will come in software as well as in manual, but we are talking about the errors which our mind keep on following. Okay, so we require a software. In the software we have to model the structure, whether it is a small building or a big Eiffel Tower, or whatever it is, the structure to be modeled in a proper way. For each type of modeling, there is a procedure. If you take for a steel structure, how you have to model, how the releases you have to give. The, for each type of structure, there is a particular procedure we have to follow. So modeling is very much important in software structural analysis. And property. If you want to do a structural analysis, you need a sectional property, material property, and the overall structure property, and loads, and boundary conditions. This is the basic factor to analyze the structure. So how it is linked with our structural analysis? You need to know which kind of member can be taken, which kind of forces. For example, for a small beam, say a bamboo string, cannot hold a 1 ton weight of water tank. How we can, how we are defining it? If you calculate the bamboo material and the sectional property with respect to load, for simplicity put, you will came to know that much of load will make the bamboo stick to fail. So it is very much important in the structural analysis. We have to choose a proper material and the sectional property for the members, and loads and combinations. The loads, any structure can be defined in a proper way by the loads. Otherwise, we will miss something. For example, if you want to design a commercial structure like a mall, you cannot apply a residential load on those floors, because it is intent of purpose to use as commercial. They will store material there. There will be a lot of people to gather there. So we have to consider those things. So for the loads, it is very much related to the purpose of the building or structure and where it is located, and so on. We will discuss it in the coming slides. And the load factors, combination and factors, it's with respect to in which kind of design we supposed to do, whether it is limit state or working stress. It depends which kind of structure we are doing and which type of analysis we are making. And the boundary condition, for any problem, we need a boundary condition. Otherwise, the problem will keep on go endless. It is the fact, even in our structural design, We need a proper boundary condition, which will make your structure stable and which will have a key point to break for our structural analysis, the load transfer point, or it will ensure which type of support we have to give for the proposed structure. Okay, and analysis. After doing all these steps, we will analyze the structure. Based on the analysis, we will get the forces, we will design the structure. Okay, these are the basic structural analysis steps or checklist or basic line, whatever you call it, but it is necessary to understand all these basic steps in a proper way so that we will not miss anything. For software, I have just listed the popular software in the field. Apart from this, there are many software used nowadays, but we'll just for presentation sake, I have listed the popular software. And all the softwares require the same amount of input, and it will give the expected output in different format. But we will get all the results in all the softwares in their own format. For example, StatPro, ETABS, SAP, and the GT Safe, MAT3D. For example, StatPro is a multi-purpose software, we can say it. We can model any type of structure, we can give any type of load, and we can do the thing and we can run the software. While we are doing a building, the heat taps will be more helpful. In which way? In the accuracy of result? No. But it will be easier in a practical way. For example, in the column, we can place the bars as we like where the site going to be placed. If you want to face the bars only in two sides, and third and the other two sides you want to keep some two dummy bars, we can keep it and we can check the results with the dummy bars. But in StatPro, we cannot do that. But we do have manual checks. So it depends which kind of software client actually want and which kind of output really we want to impose to the client. So it's both how much time we supposed to take and the costing impact also there in the software sections. And SAP, it's nothing but ETABS as a concern. The environmental will be same, but it's like StatPro only. Anything you can do it. There will be a few features not be there, which is ETABS having detailing pods. So this SAP 2000 similar to StatPro. And a GT Strudel. GT Strudel, it is used to do finite element dynamic analysis. Dynamic means for the very much important foundation like a turbine foundation or a nuclear foundation or something which to be studied properly in all aspects need a proper finite element analysis which will give you element by element of forces and results which will not be required for the regular buildings but for special buildings it's required. The GT is also one of the softwares. There are so many softwares are being used for finite element analysis like ANSYS, TrueCAD, and so there are so many softwares are available in our market for finite element analysis too. the safe and math 3D. These two softwares are used for foundation design. The safe is a byproduct of CSI, so we can get the results from ETABS app to safe, and we can model the foundation and check. And whatever we are doing in the safe can be done in SAP and ETABS and in StatPro with some kind of assumptions and a proper input of soil spring. So it is advanced software. Now we can do it very quickly with this safe and math 3D. These softwares are internationally recognized for their better outcome.